Welcome to section 6.4, solving systems of equations by elimination using multiplication. In section 6.3, all the examples had one variable where the coefficients were the same or the opposites of each other. Sometimes we may have to multiply an equation by a number to create coefficients that are opposites of each other. So in this case, you look at 3x minus 3y equals 21 and 8x plus 6y equals negative 14. You'll notice that neither the x or the y variables have the same coefficient or opposite coefficients. So we need to create opposite coefficients. And the way we do this is we look at which one would be the easiest to get opposite coefficients. Well, we have a negative 3y and a 6y, so the easiest one to get rid of, or to get opposite coefficients on, is the y variable. And to do this, we need to multiply the top equation by 2. And when we do this, 2 times 3x is 6x. 2 times negative 3y is negative 6y. 2 times 21 is 42. By multiplying the entire equation by 2, we have created an equivalent equation and has the same values. It's just we can work with this now. We're just going to bring the bottom equation over and stack it so we can add these two equations together. All right, so now we're going to add them together. We have 6x plus 8x, which is 14x. Negative 6y plus 6y goes to 0, which is what we want to have happen. One of the variables has been eliminated. And 42 minus 14 is 28. Divide by 14. And we get that x is 2. We're going to plug it into one of our two equations, our original equations. Doesn't matter which one you use. I will use the top one because the numbers are smaller. So we have 3 times 2 minus 3y equals 21. This is 6 minus 3y is 21. Move the 6 by subtracting from both sides. Then we have negative 3y is 15. Divide by negative 3. And y is negative 5. So our ordered pair is 2, negative 5. And that is our solution for this system. All right, so what we have to do sometimes is create opposite coefficients so we can add these things together and eliminate one of the variables. And that's what we'll be doing today. All right, so here it says solve each system. Make sure the variables are aligned before you do any multiplication. So the one on the left, they already aligned. We have the x's over the x's. We have the y's over the y's, constants over constants. So we want to eliminate one of our variables. So we're going to look at which one is the easiest to eliminate. And if we eliminate the y variables, we only have to multiply one of the equations. So we can multiply the top equation by 2. When we multiply by 2, we get negative 6x plus 4y equals 14. Now we're going to add these two equations together. So 5x minus 6x is negative x. Negative 4y plus 4y is 0. Negative 15 plus 14 is negative 1. Divide by negative 1 to get x positive, and you get that x is 1. We are then going to plug this back into one of our two equations. This time I'll use the bottom. We have 5 times 1 minus 4y equals negative 15. This is 5 minus 4y is negative 15. Subtract 5. We get negative 4y is negative 20. Divide out the negative 4. And we get that y is 5. So our ordered pair is 1, 5. This is our solution to this system. All right, for the next one, you'll notice that they are not aligned. We have 5y equals 9x minus 8. Then we have negative 20x plus 10y equals negative 10. We do not have things on the same sides of the equal sign. We are not stacked up nice. So we need to move the 9x over so we can stack these up. So I'm going to subtract 9x, and I'm going to rewrite the equation below. Now we have negative 9x plus 5y equals negative 8. Now we look at our coefficients and see which one's going to be the easiest to get rid of. Well, the one that's going to be easiest is going to be the y variable, because we just have to multiply the bottom equation by -2 to get opposite coefficients on the y variable. So we're going to multiply this by -2. -2 times -9x is 18x. -2 times 5y is -10y. -2 times -8 is 16. I'm going to rewrite the -20x and bring it down below so they're nice and easy to work with. And we have a -10. We're going to add these together. 18x minus 20x is -2x. -10y and 10y becomes 0. And 16 minus 10 is 6. Divide out by -2, and we get x. You forget my equal signs, is -3. Wait, yeah, it's -3. So x is -3. We're going to plug it into one of the two originals. I'll use the top one. So we have 5y equals 9 times -3 minus 8. This is 5y equals -27 minus 8. This is 5y equals -35. Divide out to 5, and y is -7. So my ordered pair is -3, -7. And this is the solution for this system. So you notice on these two equations, or systems of equations that we just did, we had to multiply by a number to get opposite coefficients on one of the variables, and then the one on the right, we also had to rewrite it so that the variables were stacked on top of each other. All right, then we're going to get a little more complicated. Here it says sometimes we need to multiply both equations by a number to get coefficients that are opposites. So you notice we have 7x plus 2y equals 26. We have 10x minus 5y equals -10. Well, we can't just multiply like the x or the y variable by another number to get opposite coefficients. As you'll notice that these are prime numbers except for the 10. We have 7's a prime number, 2's a prime number, 5's a prime number. So we need to multiply both equations. And what we want to do is find the smallest number that we can multiply by so we don't have these huge numbers to work with. And 2 and -5 are the easiest thing to get a common coefficient. And so what we can do is we can multiply the top equation by 5 to make a 10y. We can multiply the bottom equation by 2 to get a -10y. And then we can eliminate the y variable. So here we go. Multiply the top by 5. Multiply the bottom by 2. 5 times 7x is 35x. 5 times 2 is 10y. 5 times 26 is 130. The bottom equation, 2 times 10x is 20x. 2 times -5y is -10y. And 2 times -10 is -20. You'll notice when we did this, we now have opposite coefficients on the y variable. So now we can add these two equations together. 35x plus 20x is 55x. The 10y and the -10y will cancel out to 0 when you add them together. And it's going to equal 130 minus 20, which is 110. Divide by 55, and x is 2. We're then going to plug it into one of our original equations. I'll use the top one. We have 7 times 2 plus 2y equals 26. 14 plus 2y equals 26. Subtract the 14 off, and we get 2y equals 12. Divide out the 2, and y is 6. So we have 2, 6. And that is the solution to the system. Now in this system, we had to multiply both equations by a number to get opposite coefficients. And that happens quite often. All right, so here we have solved the system using elimination. I can get it on this one. We need to multiply both equations by some number to get opposite coefficients. The easiest one probably to eliminate is going to be the x coordinates. And if you look at 9 and 16, the least common multiple of them is 18. And to get 18, we multiply the top one by 2. And I'm going to multiply the bottom one by a -3 to get opposite coefficients. So 2 times 9x is 18x. 2 times 2y is 4y. 2 times 39 is 78. Do the same thing on the bottom. Negative 3 times 6x is negative 18x. Negative 3 times 13y is negative 39y. And negative 3 times negative 9 is 27. When we add these together, the 18x minus 18x goes away, goes to 0. We have 4y minus 39y, which is negative 35y. 78 and 27 are 105. Divide by negative 35. And we find that y is negative 3. Plug it in one of the two equations and solve for x. I'll use 9x plus 2 times negative 3 equals 39. 9x minus 6 is 39. Add 6. Then we get 9x is 45. Divide out the 9 to get x by itself, and x is 5. So our equation, our ordered pair is 5, negative 3. And this is the solution to our system. And again, on this one, we had to multiply both equations by some number to get opposite coefficients. So your turn. I want you to try to solve this one yourself. So pause the video and then start it back up after you solved it and see if we get the same answer I get. So here we go. I'm going to eliminate the y variable because it's smaller numbers. The lowest common multiple of 3 and 2 is 6. I'm going to multiply the top equation by 2. Multiply the bottom equation by negative 3 to get opposite coefficients. 2 times negative 7 is negative 14x. 2 times negative 3y is negative 6y. 2 times 11, 22. Negative 3 times 4x is negative 12x. Negative 3 times negative 2y is a positive 6y. Negative 3 times 16 is negative 48. We can now add these together. Negative 14x and negative 12x become negative 26x. Negative 6y plus 6y goes to 0. We have eliminated the y variable. And 22 minus 48 is negative 26. Divide by negative 26. And x is 1. Plug it into one of the two equations. This time I'll use the bottom one. 4 times 1 minus 2y is 16. 4 minus 2y is 16. Minus 4. We get negative 2y is 12. Divide by negative 2. And we get that y is negative 6. So our ordered pair is 1, negative 6. Hopefully this is what you got. That is the solution to the system. The last thing we have is our word problem of the day. The Russian Language Club is selling calendars and candles for a fundraiser. The calendars are $5 each and the candles are $6 each. You spend $38 to purchase a total of 7 items. Write and solve a system of equations to determine how many calendars and how many candles you bought. This is similar to other word problems we've seen already this chapter. We are selling two different things. We're doing calendars and candles. So I'm going to say that x is my number of calendars. And y is my number of candles. Well, the first equation I'm going to set up is my quantity equation. And we have 7 total items, so x plus y have to add up to 7. The next thing I'm going to do is my calendars are $5, so 5x. My candles are $6, so 6y. It has to be up to my total money, which is $38. All right, for this section, we are doing elimination. So we must do elimination for this. We pick one of the variables we want to eliminate. And I will eliminate the x variable. So I'm going to multiply the top equation by negative 5. And when I do that, we are going to get, and I'm going to write it below, negative 5 times x, negative 5x, negative 5 times y, negative 5y. Negative 5 times 7 is negative 35. We can now add these two equations together. 5x minus 5x equals to 0. 6y minus 5y is y. Oh, this should have been a negative 35. 38 minus 35 is 3. So y is 3. We sold 3 candles. Then we're going to plug it into the top. We have x plus 3 equals 7. And yes, I know you can probably do this in your head, but you need to write it out. X equals 4, so we sold 4 calendars. That is your word problem of the day. Same idea. The biggest thing is setting up the 2 equations, which we've done in the past. That is all for section 6.4. In section 6.4, we're still doing elimination. We do still actually add and subtract the 2 equations together, but we have to multiply by something first to at least one, if not both of the equations, to get opposite coefficients, so we can eliminate one of the variables. Thank you for watching, and have a nice day.